Section 1.5, rewrite formulas or equations and formulas. This is the last section of Chapter 1. We have one vocabulary term to start with, and that would be literal equation. A literal equation is an equation with two or more variables. I'm not going to use the phrase or the term literal equation hardly ever, if often, or hardly often, if ever. Just understand that a literal equation is an equation with two or more variables. So what we're going to be doing today is a little different in terms of what our answers are going to look like, but when it comes down to it, it's actually the same thing we've been doing with solving equations. Now we're just we're making it a little more complex, and it'll make sense a little more as we get going into Chapter 2 and into Chapter 3. So to solve a literal equation for a specific variable, all we need to do is treat the variables just like numbers and use our inverse operations. So for number 1 here, we solve for y. So if this equation said 3y plus 4 equals 9, we would know how to solve that. We would have to subtract 4 from both sides and then eventually divide by 3. Okay, but instead of having 4, we have 4x. But that really doesn't matter. We just need the 4x, this, to go to the other side. Okay, so to do that, we're going to subtract 4x, and then that rule, if you do something to one side of an equation, you have to do the same thing to the other. Okay, so now the 4x's cancel each other out, so I'm left with 3y equals, and now this part, 9 minus 4x. They are not like terms, so I can't really combine them, but I can write them with each other, or next to each other. 9 minus 4x. Okay, we don't know what 9 minus 4x is, but we know it is 9 minus 4x. Okay, so now, once we get rid of the 4x to the right side, now we need to get rid of this 3 in front of the y. We're going to do that by dividing both sides by 3. Okay, those 3's will cancel each other out. And you're left with y is equal to, now, this is what I call the heart thing, or the heart method, because you need to divide everything by 3. See how it kind of makes the shape of a heart? Real clever, I know. So, we're going to start with 9 divided by 3. 9 divided by 3 is 3. This was negative 4x, or minus 4x. So if I think negative divided by positive, I know my answer is going to be negative. 4 over 3, not a good decimal, 1.3 repeating. And it's a fraction that is already simplified. I would much rather prefer that you write your answer with a fraction rather than a mixed number or an improper, a decimal. Then I would much rather prefer this over any other way, whether that's mixed number or decimal. So I have 4 over 3, and then, whoops, need an x on the end. And this right here is your answer. Y equals 3 minus 4/3 x. That's it. We're solving the equation for y. When it says solve for y, it means get y by itself. And we've done that. Let's try another one here. Number 2, 4x minus 7y equals 12. All right, so we want to get y by itself. Okay, so the 4x, it's a positive 4x, and we want it to be 0. We're going to do that by subtracting 4x again, minus 4x. Those will cancel out. Let's see. On the left-hand side, I still have that negative sign there, so it's going to be negative 7y is equal to, and then write it just as you see it, right there, 12 minus 4x. Okay, so we've got the 7y by itself. Now we've got to get rid of the 7, and actually the negative 7. We're going to do that by dividing. Divide both sides by negative 7. So those cancel each other out. I got y equals. Now, if we think about our heart method, let's see, 12 over 7. That really doesn't simplify any farther, and it's not a good decimal by any stretch. 4 over 7, same thing, doesn't really simplify to anything. If you get something like this, where nothing really simplifies out, I am more than okay with you writing your answer like this, 12 minus 4x all over negative 7. This is a perfectly acceptable answer. It looks clean, it's all simplified, and there's nothing else you can really do to this other than split it into two parts like we did up here, what we do the first part, the second part. If you wanted to write it where you had like negative 12 over 7 plus 4 over 7x, you could do that, but I almost think that this way right here looks better for a final answer. Okay, let's move on to something maybe a little more complex. Number 3, solve y equals 3x plus 5xz for x. Okay, so in the first two examples, we just had the one variable that we were looking for. But here, we're looking for x, but we have two x's in our problem. So the question becomes, which one? Well, there's only going to be one, and I'm going to show you how we're going to do that. So I'm going to rewrite this, y equals. Now, notice that both of these terms in the right-hand side of the equation have an x. Okay, so what I'm going to do is I'm going to basically undistribute. So that's going to be an x. And if I take an x out of both of those terms, what's left? Well, think about undoing the distributive property. X times what would be 3x? Well, that would be 3. And then x times what would be 5xz? Well, if I take the x out of there, I'm left with 5z and then a plus in between. Okay, so now I've got, let me erase these little arcs. I've got x times 3 plus 5z. I've undone basically the distributive property. Okay, undone the distributive property. Now, let's, this is x. 3 plus 5z is a number. We don't know what it is, but it's a number. So if I had x times 7 equals y, whoops, y, and I want to solve, this is times. If I want to solve for x, all I'd have to do is divide by 7, right? So instead of dividing by 7, get rid of this, we're going to divide by what we're multiplying x by, 3 plus 5z. It looks a little different, 3 plus 5z. Could you do the heart method here? Sure. But when it's upside down like that, it's not really necessary. Though that whole thing cancels out, and we're left with x equals, I'm just flipping the equation over, and then really this becomes our answer right here. Y over 3 plus 5z. That's our answer right there. We've got to undo the distributive property and then get rid of whatever we're multiplying x by to get our final answer. Whoops, and then for number 4 here, I missed a part of the equation. This should actually be 3w plus 4wp equals a. We're solving that for w. Let's try it again. So we've got w and w. We've got two w's. Let's combine them by undoing the distributive property. So w times, so if I was going to distribute, w times what would give me 3w? And the answer there is 3. And then w times what would give me 4wp? Well, that answer there is 4p. And then a plus in between, that's equal to a. Okay, one last step. We need to divide both sides by 3 plus 4p because we want to get rid of this. That takes care of that. And if we're going to divide by 3 plus 4p on the left side, we've got to divide by 3 plus 4p on the right. So these go away on the left. We're left with w equals a over 3 plus 4p. The biggest takeaway here is if you've got multiple letters, or if you're given a task like these two here, where you're solving for a particular variable, but there are two of the same variable that you're looking for in your equation, what you're more than likely going to have to do is undo the distributive property. Okay, I would definitely write that down. Pause the video, write that down. If you have more than one variable that you're trying to solve for, I would see if you can undo the distributive property. And then it makes it real easy once you get that done to get the variable you're looking for by itself. Okay, let's try a couple more. Number 5, solve 2x plus kx equals m for k. So now we have two x's here in our equation, but we're not solving for x, we're solving for k. Okay, we're just solving for this k value. So anything not directly attached to k needs to go away first, and that would be obviously the 2x. So we're going to subtract 2x from both sides because I want it to be 0, minus 2x. So those will cancel. I'm left with kx on the left equals m minus 2x on the right. I don't know what m is, I don't know what x is, but I know it's going to be m minus 2x. Okay, so now I've got k almost by itself. I got to get rid of this x. This is k times x. To undo multiplying, we need to divide. So I'm going to divide by, well, I'm going to divide by x. Divide that by x as well, because those will cancel and I'm left with k. Again, this is another example where, if you want to do the heart thing, you certainly could. So we do m over x, and then negative over positive would be a negative answer. 2x divided by x, well, the x's will actually cancel each other out there, and we're just left with 2. If you want to just leave it as m minus 2x all over x, I am okay with that as well. So either one of these two answers is fine. They're exactly the same. It's just your preference on which you would like to do. Let's try one more here. I equals PRT for t. Okay, so this is all multiplying, p times r times t. So this one's actually going to be pretty simple. If I want to solve for t, and I'm originally going to take t times p and times r, to undo multiplying by p and r, we should just divide both sides by p and r. P and r. Okay, so the p's cancel, the r's cancel. Right hand side is left with t, which is what we want because they're solving for t. And then I over pr. We have no idea what I, what p, and what r are equal to, so we just have to leave it as I over pr. That's actually our final answer right there.